Hello students and welcome to another video. I'm your teacher, Mr. Flynn, and today we're going to be talking about nuclear fission. Okay, there's two vocab words I want you to write down. Okay, the first one is the definition for what is nuclear fission. And nuclear fission is the splitting of a nucleus into smaller fragments with the release of neutrons and a large amount of energy. Okay, so we're taking a large unstable isotope and we're breaking it apart. And then fissile, okay, refers to like fissile products or things that we use to break down are just basically any type of atom that can undergo fission. It's considered fissile. Okay. Now let's look down at this picture and appreciate it. So we've got a uranium-235. This uranium isotope was used in World War II to create the first atomic weapons used on Japan. And the idea is we take a neutron and we fire it at an unstable uranium atom, and it will elongate. This strong force is broken, and the electromagnetic force kicks in, and they repel each other, and they form barium and krypton. They can also form other different types of daughter isotopes, but in this example, they use krypton and barium. And what happens is it then releases more neutrons and releases a ton of energy, okay? And that energy was used in the war, okay? The same energy can also be harnessed in a nuclear reactor where we can produce clean energy. But there is downsides to using nuclear radiation. Part of the problem with this process is if it is a chain reaction, right? We have a neutron hitting a uranium, it's splitting, and it's releasing 3 more neutrons, which are going to go bombard other uranium-235s. So it forms this chain reaction, and learning to control that chain reaction is vital to creating a safe form of energy. While when we create a weapon, we don't care what's happening. It's going to continue to break down and ignite other uranium-235s to split, and it's a chain reaction that happens very quickly. Okay, and there's a whole controversy we'll do in class, and we'll talk about the different types of nuclear energy and why nuclear energy is still around today, even though it's so dangerous. Okay, and for example, nuclear energy doesn't release CO2 in the atmosphere like oil or natural gas and other forms of fossil fuels. And it's destroying our environment with the carbon dioxide in the air. While this is just basically heating up water, and it turns into steam and turns these engines. So it really isn't a pollutant. It's just a lot of people are nervous about this reaction occurring because it can melt down. For example, in Chernobyl, there was a reactor. Reactor 4 failed during that Soviet era. I think it was in the 80s. Yeah, it was in the 80s, where one of the reactors failed, releasing large amounts of radiation in the atmosphere that flooded Europe. Okay, and as you learn more about radiation, it's not safe to be around it, especially in such concentrated volumes, which are used in nuclear power plants. Okay, they actually put a big dome over it to cover that reactor just back in 2017, I believe. So it took about 30 years for them to finally clean up the mess. So nuclear fission is a great way of creating energy, but it's also can be a dangerous form of energy that we are forming. Okay. All right. Thanks for watching. Until next time.